Waves have energy. Whether it's sea waves, the light waves of a laser beam cutting through steel, waves in the Earth's crust causing earthquakes, or the waves which made the Tacoma Bridge shake itself apart in 1940. To take a closer look at how they behave, waves are best studied in a tank of water. The water appears to be moving from right to left. Pushing a dipper into the tank at one end produces a series of simple waves. The waves move along, but place a float in the water and it stays where it is. So what is moving, and in what direction? To look at waves in more detail, models have been devised to help explain their motion. Focus on just the orange spot and you'll see that it moves up and down. It oscillates. Although the waves travel from right to left, the particles on the surface of the water are simply bobbing up and down. This movement is at right angles to the direction in which the waves travel, so it's called a transverse wave. These waves are both transverse, but they look different. The difference is the distance from one peak to the next. It's called the wavelength and is measured in meters. The top wave has double the wavelength. Another characteristic of a wave is its frequency, the number of complete waves which pass a particular point every second. Change the frequency and see what happens to the wavelength. How are frequency and wavelength related? You can produce a simple transverse wave by moving a spring from side to side. Another type of wave is given a different name. This time a pulse is sent along the line of the spring. It's called a longitudinal wave. Fix a marker to one part of the spring and you can see that once again there's an oscillation. But this time the motion is backwards and forwards. For both types of wave, energy is transmitted along the spring, but the spring itself doesn't move forwards. Energy is transferred, but matter isn't. Light waves and water waves are both transverse. Sound waves are longitudinal. They're a series of compression waves travelling through the air. Earthquakes are caused by both transverse and longitudinal waves travelling through the ground.